Hi, this is Mr. McGovern. In the third video of the Electromagnetism series, we're going to look at the magnetic field around a moving electron. So you already know that we have an electron, there's an electric field around it. It points inwards because an electric field always points the way a positive test charge would go if I dropped it. So if I dropped a positive test charge anywhere, it would be attracted towards the negative electron. That's why the arrows go in. So this is an electric field. It turns out when an electron is moving, it produces a magnetic field. Okay, so electric field and magnetic field, for you at level 2, they are different things. You need to keep them separate, even though there's the word field in both of them. It's a very common mistake for people to mix them up. So a moving electron makes a magnetic field. And that magnetic field goes round in loops around the electron, and it's circular. Now we learned in the last video how to draw field lines coming into the page and out of the page, and so instead of trying to draw these loops around a magnetic field like this, the way we draw it, this is a similar electron, is we draw just dots for a field line coming out and then crosses for the field line going in. You can imagine joining the loops up with those dots and crosses. So instead of drawing the picture on the right, we like to draw the picture on the left because it just shows no confusion about with the loop, where the loop's coming out of the page. That's what the dots are, coming up towards your eyes, going in front of the electron and then back down away from your eyes there. So these two are equivalent, but we like to draw it on the left. The way we come up with and figure out which direction these are, and therefore what the dots and the crosses are, is we use our left hand rule. So we hold our left hand with a bit of a grip there, and our thumb points in one direction. The thumb points the direction that the electron's travelling, and the way your fingers are curled is the direction of the magnetic field. That's the circular direction of the magnetic field around the electron. So let's go back to this one we've already done. The electron looks like it's moving to the left, so I point my left hand to the left, and you can see the way I'm gripping my fingers is the way those field lines go around that electron. And like I said, I like to draw it with dots and crosses instead of drawing it with the circles like that. Sometimes the circles can get a little bit confusing. And so I'm just holding my hand in front of me and seeing how above the electron, if imagining I'm grabbing the electron in my left hand, above the electron my fingers are pointing towards me, and as I grip and grab around below the electron, so I rotate my hand around, my fingers point into the page, and that's where the crosses come from. So throughout the topic, many teachers are going to teach you a number of different hand rules. So if you are taught by a teacher other than me, you may get a right-hand grip rule, a right-hand slap rule, Fleming's left-hand rule, and Fleming's right-hand rule. A bunch of different rules can get things very confusing. And so I have to give full credit to my co-teacher, Mr. Lau, who's taught me this one, which is just a single rule. Okay, the learning the left-hand rule for electrons means you can solve everything in level 2 with only one hand rule. It makes things, especially if you want to understand things at a deep level, makes things much better. Now, I just also want to stress again that electric fields and magnetic fields are different. Okay, electric fields occur around an electron, but magnetic fields are only produced around moving charges. So when electrons are moving, you only get a magnetic field.